Hello everyone, Siddharth this side, and in this video we will be solving another question from the list that I have shared with you. And this is hash 11 on lead code, which is container with most water. So we have given an integer array, and each element is representing the height of the line, and or we can say the boundary of the container, imaginary container. And what we have to do here, we have to choose those line. If we try to make the container with the x-axis between with the help of those two lines, then we should have to store the maximum amount of water between between that imaginary container with the x-axis and those two lines. So how we can approach this question? So obviously we will be using two pointer here because we are currently on two pointers approach. Now I would say that you can pause for a moment and try to think how we can solve this question using two pointer approach. So now let's see how we can solve this question. So suppose this is one line and this is one line. So this is left pointer and this is right pointer. Now if we have if we want to try if we want to find the area between these two, or the amount of water between these two lines, that what we can do, first we have to find the smaller line, because no matter what, how much the height of this, or the height of the bigger line uh, is not mattering here, because it will not contribute, or it will because this due because of the smaller line, the water will get overflowed. So that's why the smaller line will be contributing to the amount, or the amount of water that will get stored between these two lines. So we just have to apply a condition that we have to move on to the side where we have to find that line which is smaller. So this is one concept that we will be using here. And then how we can find the area between these two, that will going to be the width of this rectangle and the height of this rectangle. So that will going to be the area is equals to width into height. Now how we can find the height? We can use the condition that minimum of height on the left side, and uh, minimum on the height of the left side and minimum on the height of the right side. So this is the condition that we can use, and we will be updating our max area and keeping track of the max area, so that we can find we will be returning that area only which will be or which is giving us the maximum amount of area. So now let's code this out as well. So first we will be initializing the left pointer with 0, then right pointer as height -1, height dot length -1. Now then let's initialize the area as well. So max, let's name it as max area, and we will be initializing it with 0 in the start. Now let's start same thing in the two pointer approach. So that we have done in the two pointer approach. So then we just have to check that left should be less than right, and then after doing this we have to just find here also, we just have to find the smaller line, and we have to calculate the area as well. So for that, first we can calculate the width of the current rectangle that we can make by using these two lines. So int width, the formula for this is right minus left. So this will give us the width, which is the index of this line and index of this, we will be subtracting the this, then this will returning the width of this rectangle. Let me draw it also for you so that you can easily see. So this width we can calculate as left minus right minus left. So after calculating this width, we have to calculate the area as well. So for that, current area we can say, so current area will going to be width, and the height also we have to calculate. So for that we can use we can use another formula for calculating the height, that will going to be uh, int height is equals to, or we can say this as min height, and it will going to be um, math dot minimum of math dot minimum of the element which is at the starting index, and the element which is as the last index. So which will going to be HEIGST, and that will going to be left, then HEIGST, that will going to be right. So width we have calculated the minimum height, and then we have to calculate the current area, that will going to be width into height. So VIWIDTH into minimum HEIGST. So this will give us the current area. Now we just have to update our current area. So max area. So max area is equals to math dot max of the current area and the minimum area. Also, current area and the maximum area. So this line will keep track that we will only be carrying forward the area which is maximum. Now, what we have to do? Uh, we have to check whether, so if the element, so for that, if the element which is as the left index, so HEIGST, if the element which is at the left index or the line, if it is its height is smaller, if its height is smaller on the if its height is smaller from the element which is at the last index of the array, so if this is the case, then we just have to move from the move to the right side of the array, because we want to explore all the possible. Suppose let me draw another one. So suppose we have encountered this also, this uh, this line, then we have to move from this block to this block, because uh, it is possible that in the future we are encountering an element whose height is too much small, that it is covering uh, the width that we have lost, and it is covering the width loss that we have done after moving on to the right side, and also like it is adding the height part too much. That's why the multiple of these two is getting bigger than the maximum area that we will be or we are carrying up to this point. So for exploring all the parts or all the possible combination, we have to move to the left side of the array, and otherwise we have to move to the left side. Okay, now after doing this, we just have to return the max area. So max area. Now we can try to run this question and check. Okay, now let's try to submit this as well. So we have successfully solved this question. So see you in the next video. Bye.